Here in this video, basically it doesn't discuss the axial flux. It does bring up the homopolar generator. Basically only discusses the radial properties of the Zeldovich effect. It does not discuss the homopolar effects of the axial flux design. It doesn't touch on the rotating Tesla coil design. It doesn't touch on any of these things. But the most important part, it does show the physics that exist, and it doesn't break any laws of physics. And this really could be a path to a future to where we are not burning coal or burning oil or destroying our planet. So enjoy the video.
Welcome to today's Explainer. Look, today we're doing something wild. We are bridging the terrifying astrophysics of black holes with the macroscopic engineering of our future infrastructure. We're looking at a paradigm shift so profound it could literally change the way human civilization powers itself. We're going to explore how a mind-bending concept from 1970s theoretical physics has actually been proven in a modern laboratory and exactly what it means for the machines of tomorrow. So let's get right into it. To really grasp this shift, we've got to challenge an assumption that's been baked into electrical engineering for 200 years, and that's the idea that every generator inherently has to fight its own back electromotive force. For centuries, we've just accepted that motion encounters drag, right? The harder a machine works to produce current, the more aggressively it resists its own motion, thanks to Lenz's law. Think of it like trying to run in waist-deep water. The faster you try to move, the harder the water pushes back at you. Resistance is just built directly into the architecture of the machine. But what if it didn't have to be?
The crazy thing is, the clue to beating this drag has actually been staring at us since 1831 with Michael Faraday's early homopolar generators. These were curious little spinning disks that yielded high current and low voltage, completely avoiding the friction-heavy alternating magnetic fields we use today. Current just flowed continuously through a rotating conductive surface. They didn't rely on constantly reversing those fields. By rotating the conductive medium and the magnetic geometry together as a unified system, they effectively bypassed conventional inductive drag. So it proved early on that resistance is, at least in part, just a geometric consequence of how we design our machines.
Okay, so this is where things get super weird, and it brings us to a concept first proposed back in the 1970s. In astrophysics, if waves bounce off a rotating absorber, imagine a black hole surrounded by a perfectly reflecting mirror, they actually steal its rotational energy. Each reflection returns stronger than the last. Amplification feeds amplification until the entire system literally explodes. In theoretical physics, this is known as the black hole bomb instability. I know, it sounds like pure science fiction, right? But the math behind it was absolutely rock solid.
Then along comes Yakov Zeldovich, a Soviet physicist, who realized something massive. This wasn't just for black holes. Any rotating, absorbing cylinder could amplify electromagnetic waves, provided it spins fast enough. He calculated a deceptively simple relationship. Basically, if the rotational velocity of the cylinder exceeds the frequency of the incoming wave, the wave essentially pulls energy from the spinning system. The rotating body slows down, and the wave gains energy. This is called rotational superradiance, and it is absolutely central to everything we're discussing today.
So, practically speaking, this breaks down into three distinct states. First, if you have no cylinder, the wave just passes on by. Nothing happens. Second, introduce a cylinder, but have it spinning slower than the wave's phase velocity, and you get your classic drag and absorption. But state three is where the magic happens. Spin that cylinder faster than the wave, and suddenly, you're amplifying the wave. The rotor stops being this passive object and becomes a totally active participant in field amplification.
But here is the kicker. This didn't just stay locked away in theoretical math. A team at the University of Southampton actually built this device. They used an aluminum cylinder with an air gap of just 1 millimeter, bringing the Zeldovich effect out of the cosmos and right onto a laboratory workbench. Nested inside a three-phase induction motor acting as a stator, their setup allowed them to generate a magnetic field with a definite rotational direction directly on top of that spinning internal cylinder. In the lab experiment, external coils generate a quadrupole magnetic field. Imagine a four-poled magnetic structure that physically rotates around the inner cylinder. The really clever design of these coils leads to a mode where the magnetic field completes exactly half a rotation for every full cycle of the sinusoidal current in the circuits. And as that field completes its rotation, its momentum physically acts on the cylinder.
This insanely tight geometric control lets researchers pinpoint the exact, precise moment the interaction shifts from typical resistance to something entirely different, setting up the exact conditions to trigger the rotational superradiance we just talked about.
So here is the exact threshold. It's the turning point. When the cylinder's rotation frequency surpasses half the frequency of the incoming electromagnetic wave, the system exhibits what's called negative resistance, which means it starts feeding energy back into the wave. For centuries, we thought motion absolutely had to consume energy. But right here, the script flips entirely. The rotating system transfers its kinetic energy directly into the electromagnetic field. Absolute gain.
Now, get this. When researchers ran this in an open-loop setting, seeded by nothing but background noise, the rotational energy converted into electromagnetic energy so violently that it caused runaway self-oscillation and actually blew up the resistors. Seriously, literal explosions in a highly controlled lab. This wasn't a metaphor. The exponential amplification of those spontaneously generated electromagnetic modes proved the exact mechanics of the black hole bomb. The system literally fed on its own rotational momentum until the components just couldn't handle the power anymore.
But rotation alone isn't going to power a city. Amplification without containment is totally temporary. You need a resonant cavity. Think of the lossy mirrors in the lab's RLC circuits. You need something to trap the wave and force it to bounce back and forth, extracting more energy on every single pass. The cavity is the missing piece of architecture here. It's the boundary that refuses to let the signal escape, forcing the wave to synchronize and literally compound its energy recursively.
So how does a bench experiment change the world? Well, this proven physics lays the groundwork for an incredibly ambitious theoretical framework called the Sovereign Engine manuscript. It basically proposes retrofitting our existing heavy industrial turbines with resonant cavities to completely decentralize and transform our power grids. Think about it. We have massive, high-velocity rotating systems everywhere. Power plants, industrial centrifuges. The manuscript suggests treating these not as extractors of energy, but as potential amplifiers. By enclosing them in tuned cavities, we could create sovereign buffers, shifting away from a fragile, centralized grid to a robust network of independent resonant nodes.
But obviously, we don't want our local power grids blowing up like those lab resistors. If a machine can amplify energy exponentially, it can also tear itself apart. A system can produce extraordinary energy and still collapse into total chaos, because without perfect synchronization, waves interfere destructively. That is exactly why future engineering relies heavily on phase locking to keep the amplification perfectly stable. It orchestrates the timing so the system behaves as a single harmonious structure, completely preventing that chaotic runaway effect.
To do this safely, a sovereign engine needs strict stability criteria, including active adaptive feedback to instantly detune the cavity if the amplification threatens to melt the hardware down. You basically need to be able to miss your own resonance on command. This means swapping out old traditional mechanical governors for incredibly fast, high-speed predictive algorithms. If things get a little too hot, the system intentionally initiates phase decoherence, throwing the waves completely out of sync to instantly mute the amplification before a catastrophic failure ever happens.
And materials matter here big time, because even a 1% thermal loss could be an absolute disaster. We're going to have to rely on advanced metamaterials and superconductors to create near-frictionless, perfectly reflective environments. Traditional metals, they just vaporize under this kind of stress. We are talking about engineered geometries that manipulate electromagnetic behavior down at the structural level. In these future systems, the material of the enclosure itself acts as an active, crucial participant in the amplification process.
Ultimately, what we are talking about is a profound philosophical shift. We are moving away from an era where we violently extract and burn fuel against mechanical resistance to a future where we synchronize and tune machines to their electromagnetic environments. Think about the loud, vibrating combustion engine sitting in your car right now. For the last century, we have fought the environment with pure brute force. Need more power? Burn more fuel. But the Sovereign Engine framework proposes an entirely different economy. An economy of coherence, where precision, phase alignment, and resonance completely replace raw consumption.
There's this beautiful line from the manuscript that perfectly captures the essence of a civilization finally mastering the geometry of energy rather than just relying on brute force. It says, "The future machine may not roar, it may hum." A machine built on combustion is incredibly loud because it's constantly fighting resistance, but a coherent machine, perfectly phase-locked within a resonant cavity, operates with almost zero friction. It doesn't try to dominate its environment, it synchronizes with it.
creating just a quiet, continuous hum of absolute efficiency. So I'll leave you with this. As we look toward a future powered by coherent planetary infrastructure, we have to honestly ask ourselves, are we finally prepared to leave the age of combustion behind? The laboratory physics isn't science fiction anymore. It's real. We've seen a rotor amplify a wave. We've witnessed negative resistance in action. So the real question is, when this technology scales, are we ready to radically rethink our entire relationship with energy? To move from a civilization that just blindly consumes to one that perfectly resonates? It's a huge, paradigm-shifting thought to end on. Thanks for exploring this amazing concept with me in today's Explainer, and I'll catch you next time.